Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, evaluate reverse polish notation. So basically there's one algorithm reverse polish notation. So we are required to just implement this notation. That is all about this question. So now first comes the part that what exactly reverse polish notation is. So if we are given with 2 plus 3, then it would be written as 2, 3 and then plus. So this is the reverse polish notation. If there are some more operands and operators, then it can be written directly like this. Means whatever operands are there, so those would be written first and just immediately to that whatever operator was there that would be written here, and then the operand, then operator, and then the operand, and then the operator. So this is how this notation is being written and it is being evaluated like this. So the thing is that what we are required to do in this question would be that whatever operands are being given to us, we are directly required to check for those operands, and then whatever operator is being given to us according to that, then we will be means say if we take this particular thing, then how we will be evaluating this would be something like this only, right? So we just need to check for operators, whatever operator is being given to us, then we will be checking that, and after that whatever operand was there previously, we are required to evaluate both of those operand according to this particular operator. So this is the thing which we are required to do here. Now comes the part that can we do it directly or do we require some data structure? So here either we can use um, iterative stack, or we can use the recursive stack, or we can directly go ahead with unordered map as well. But here in this solution, I will be showing you with the stack that how iteratively with the stack we can do this particular question. So before going ahead with the implementation part for the same, let us check for the constraint. According to that only, we will be required to check that all other operations which are there till what value they can go. So here the length could be 10 raised to power 4. So that simply means that total 10 raised to power 4 elements could be there in our input, and these will include operand, operators, both of them. Now this thing which is there, it is either these operators or it could go up to this much range. Means 10 raised to power 2 into 10 raised to power 2. So it can go up to 10 raised to power 4. This is that max range in which it can go. But the thing is that while doing the multiplication part, it can go up to, means it can go till any range, means it can exceed the int range as well, because here we are having this 10 raised to power 4 elements, right? So that's why rather taking int as a data type, we can take the long int for eradicating that integer overflow situation. So now comes the part for the implementation of the same. So here, how we are required to implement the same is that the algorithm which is being there, we are just required to implement. That's all. So here I'm using the stack, and there I'm using long int rather than using just int. And then this is for that fact. See, whatever operand would be there, I will be pushing that into my stack. And then whatever operator I got, rather than pushing it into the stack, what I will be doing is I will be popping out whatever was there and then directly doing the operation. And then after doing this, then my stack would be, if this was the only operation required to be done, then my stack would be empty. And then after whatever answer I got, then I will be pushing that to my stack. And then I will be moving ahead in whatever operand and operator would be there. So according to that, I will evaluating my next expression. So this is the thing I would be implementing in this particular question. So now here, see, if I got some operator, say if I got plus, then what I will be doing is I will be popping out from my stack and then performing the operation and then pushing whatever answer I allocate to my stack again. If I got minus, so I will be doing OP minus OP2 minus OP1 rather than doing OP1 minus OP2. Why? Because see, it would be something like this. Say it is something like this, right? So we pushed here, then we pushed here. Then here the expression should be evaluated like this. But if I will be pushing it out, popping it out, right? So my OP1 would be this 5 and OP2 would be 3. So it becomes expression like this. But we are not required to do means this is OP1 and this is OP2. We are not required to do like this. We are required to do like this means OP2 minus OP1 that is 3 minus 5. So in that context only I am doing this. According to your implementation, you can go ahead but I implemented like this, so that's why I'm doing like this. And then here multiplication, it doesn't matter, but only thing would be for this long int, which we have already checked. Then comes the part for this division. For this division, we are required to check that it is not divided by 0. That is the thing which we are required to check. So for that, I've already checked that if my OP1 is not equals to 0, then only I'm performing the division. Else I will be pushing the int max to my stack. So that is the thing which we are required to keep check on. Means basically these are some of the cases which can give you wrong answer. And then if any of these operators are not there, then we are required to directly push our operand. But pushing our operand, that also we are required to convert that to integer, and that's what I'm doing by this inbuilt function story. And then after all these if else conditions are completed and this for loop is ended, then we are directly returning whatever is there at the top of my stack. Because at the top of my stack there would be just one element, and that's what I am required to return. So that is the thing which I will be returning, and that's why I'm returning h.top. So this was all for this particular question. But now comes the part about time complexity. So time complexity for the same is we are just doing operation on the stack. Uh, Checking means traversing this whole input. So it's order of n only. And space complexity is also order of n. Why order of n? Because we are using a iterative stack here. So that's why it is order of n. Hmm. Yeah. So this whole question was directly one implementation only. So yeah, this was all for this particular solution. If you have any doubt, you could comment it down. And yeah, thank you.